All right, section 2.2 is all about slope and rate of change. Now, rate of change is the same thing as slope. So this "and" is kind of misleading. Slope is the same thing as rate of change. This should be review, but we're going to throw down the nuts and bolts really quick. Slope can also be represented by the letter M, which makes complete sense because there's an M in. I don't know why M is. I didn't go and make that up, but M means slope. And then the formula to find slope is y sub 2 minus y sub 1. That's subscript to differentiate between one y coordinate versus the other y coordinate. And we got x sub 2 minus x sub 1. Another way you often see it is this subtraction, this difference. In science, they like to use this triangle thing. This triangle means the change in y. It's called delta y, or the change in y divided by the change in x, or delta x. And then everybody remembers rise over run. Now, all of this is all to describe slope, where x sub 1, y sub 1, and x sub 2, y sub 2 are any 2 points on the line. Alright, this is always going to be true for any 2 points on a line. Now, many of you are probably familiar with, the slope formula, y2 minus y1 divided by x sub 2 minus x sub 1. And if you like it, that's awesome, go for it. I'm going to show you another way that I learned that I think is pretty nifty, and you're welcome to use that as well. First of all, let's talk about what slopes can look like. You read a slope from left to right. So for example, in this case, from left to right, this line is going up, thus this has a positive slope. From left to right, this is going down, so this has a negative slope. Where it gets tricky, and when it looks like, oops, sorry y'all, when it looks like this, a horizontal line versus a vertical line. Now, in middle school, you may have heard the term no slope. I never, ever, 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 never, ever, ever, never want to hear no slope. A horizontal line has a slope of 0, and we'll talk more about why during class tomorrow. But a horizontal line has a slope of 0. A vertical line has a slope that is undefined. And again, we'll talk more about why during class tomorrow. Or just ask me, and I'll tell you what's up. I'll tell you a little bit about why now. Check out the 0 slope. To get from this point to point A to point B, what's our change in y? What's our rise? It's none. And our run, let's say, is, I don't know, 3 units. If you use your calculator, 0 divided by 3, you'll find that 0 divided by 3 is indeed 0. So that's why this is a 0 slope. But undefined, to get from point A to B here, your change in y is, say, negative 3 over your change in x is 0. Negative 3 divided by 0, remember, when 0 is under, it's undefined. All right, and I got a thing with a ruler that I'll show you more about what's up here. Couple things to remember about slope. The larger the absolute value of the slope, the steeper the line. The steeper the whole line. Parallel lines have you should remember from geometry, parallel lines have the same slope. And perpendicular lines have, anybody remember? Opposite reciprocal slopes. All right, so that's the nuts and bolts old review of slope. Let's do one example before the video is done. Example 1, I want you to find the rate of change. Remember, what's this another word for rate of change? That just means slope. Of the line through, I'll give you 2 points. How about negative 3, 5, and 2, 1. All right. So here's what I like to do. Before I even get started, I like to draw a quick little coordinate plane, nothing fancy, and just make quick coordinates of this. So negative 3, 5. Notice it's not exact or anything. 2, 1. I just ballpark where these points would be at, and then draw a line through those 2 points. Now check this out. By doing that, I can already see what kind of slope I should expect to find. From left to right, this line is going down, thus I expect to find a negative slope. So, if you like doing the slope formula, m equals y2. Does it matter which one is y2? It does not. And, I can prove that to you if you like as well. 5 minus 1 over, you take the y coordinates, subtract them, over the x coordinates. Now, since I started with this y, I have to start with this x. So this would be negative 3 minus 2. So this is 4 over negative 5. We have a negative number just like we expected. From our picture, we have a negative slope. Let me show you this again real quick. Suppose that I made this. Suppose I started off with 1 minus, and then I did the 5. That's fine, but then I have to start with the 2 again. 2 minus negative 3 is the same thing as plus 3. So this would be negative 4 over 5. Doesn't matter which one you start with, but you always got to start with the same one as well. Yeah, so that's the slope formula. I want to show you another way that I recently learned about that I kind of like. What I like to do is I like to take both the points and stack them. So negative 3, 5, and I got the point 2, 1. And I like to do what I call the jumps. And what I do is, how do you jump from negative 3 to 2? How much do you got to move? Well, to go from negative 3 to 2, you got to go up 5. Then, how do you jump from 5 to 1? Well, to get from 5 to 1, you got to go down 4. Right? So, slope is the change in y divided by the change in x. So, in this case, the change in y, these are my y coordinates here, negative 4 divided by 5. It's no different than using the formulas, but the jumps, I don't know. To me, it just seems a little cleaner for some reason. All right, we'll see you tomorrow. Smith out!